In this video lecture, we are going to look at some different concepts of logarithms. So we're going to look at solving them without a calculator and converting them back and forth between logs and exponential forms. So for these first couple examples here, what we're trying to figure out is what exactly is the log base 5 of the number, or what exactly is this evaluated at. And we're going to use this rule here that we have, which says if y equals the log base a of x, then x equals a to the y. And so essentially what that does is it allows you to look at the logarithm you have and try and see if you can find it. For example, I have the log base 5 of 625, and I want to know what that is. So I can rewrite that as 5 to the x is equal to 625. In other words, what do I need to raise 5 to in order to get 625 as an answer? So we can look at doing the same thing we did, or you would do with exponentials, which is to rewrite 625 in terms of the base of 5. Or you can, in your head, start doing, okay, 5 to the first doesn't work, 5 to the second doesn't work, 5 to the third doesn't work, and so on and so forth. So those are the two approaches you can use. The approach that I like to use is I like to go ahead and pull on my exponential ideas. And I know that 5 to the fourth gives me 625. Therefore, my x is equal to 4. Now this one here I have is 1 over 64, so we need 4 to the something equals 1 over 64. Well, with that, I know here I could apply a negative rule, so I get that 4 to the x is equal to 64 to the negative first power. I also know 4 cubed gives me 64, therefore x is going to be negative 3. The last one is base 9 gives me 3, so that says 9 to the x is equal to 3. Well, if we think about it, this is the same as 3 to the first, so we need to go ahead and change this. So this becomes 3 squared. Don't forget that x was there, and this equals 3 to the first. Therefore, we have that 2x is equal to 1, so x equals 1/2. Alright, so we can expand on that rule idea and do what's called conversion. So here all we're simply doing is we're trying to convert an exponential form that we have over into its logarithmic counterpart. And so here that's going to pull on the exact same knowledge that we have, and so we're going to end up with the log base 3 of 1 over 81 is equal to negative 4. And that's coming from the rule that we just discussed, which says if we have x equals a to the y, then y is equal to the log base a of x. So we're using just the idea of this rule to go back and forth. Okay? So over here I have e to the negative x, so this is going to become log base e to the 5 is equal to negative x. Alright, now here we've got the log forms we want to convert back over into their exponential counterparts. Okay. Oh, and coming back here to this example here, we have a generic rule that says anything log base e can be written as the natural log of 5 equals negative x. So theoretically or technically either one of these two answers would work. but I just wanted to point out that this log base e point has its own little definition, which is natural log. Alright, so now these other two examples, like I was saying, are in log form already, which means we want to shift those back over into the exponential form. So here this first one is going to be 8 to the negative 2/3 is equal to 1/4. And on this bottom one, we're going to have 6 to the 0 is equal to 1. Now notice we're not actually trying to solve or simplify, we're just simply converting it from one form over to the other. Now the reason we were doing all of that was to prepare us and get us ready for solving the equations, because solving them sometimes means having to go back and forth, similar to what we were doing in the very beginning. So here I have the log base 8 of x is equal to negative 1/3. So in this case I can rewrite it as 8 to the negative 1/3 is equal to x. And so here we would go ahead and be able to solve. This negative would be, say, the negative rule. So we would end up having 1 over 8 to the 1/3 is equal to x. Well, 1/3 is the same as a cubed root, so this is 1 over the cubed root of 8, which equals x. And we know the cubed root of 8 is 2, so what we actually end up here is that x is 1/2. Let's look at another. Here I have 1/9, and we're going to raise that to the negative 1/2 and say that this equals x. Okay. So here what we have is we have the negative rule, which the negative rule says we're going to flip our reciprocal, so we're going to end up with n to the 1/2 is equal to x. Well, the 1/2 power is the square root, so this is the square root of 9 is equal to x, and we know the square root of 9 is 3. Let's look at this next one. Here we've got log base 2 of 16 to the 2x equals negative 4. So this is 2 to the negative 4 is equal to 16 to the 2x. We need to make our bases the same, so this is 2 to the negative 4 is equal to 2 to the 4 times my 2x. So this is 2 to the negative 4, which equals 2 to the 8x. So we get negative 4 is equal to 8x. And so negative 1/2 is equal to x. Last we have the natural log of x minus 3 equals 7. So here we've got the log base e of x minus 3 equals 7. Now the reason why I rewrote it like this is so that I can change its form. So this becomes e to the 7th is equal to x minus 3. So here we end up with e to the 7th minus 3 is equal to x. Now this right here would be what's called your exact answer. And then we could evaluate that, and we end up getting 1099.63 is equal to x. This right here would be your approximate answer. So that in a nutshell is everything you would need to know to kind of get going and get started with looking at logarithmic functions, how to solve them and convert them back and forth between logarithmic and exponential. So if you have any questions, please let me know. Otherwise, be creative. I do hope you enjoyed your math, and I hope you enjoyed this video, and I'll see you next time.